What's going on, guys? Welcome to LetThereBeMath again. And in today's video we're going to be looking at a very interesting integral, which is x to the power of 99 times tan of x to the power of 100. Now you might be looking at this integral and wondering, well, how exactly can we integrate this whole thing? I mean, it's a silly function in itself, but does it even have an integral? And the answer to that is yes, and we're going to see how we can actually manipulate this expression to get it into a form that we can actually use to our advantage. Now, the first thing we should note is that we have a tangent function here, so one good thing to do whenever we're not sure about how to go in the next step is to represent this in terms of simpler functions. In this case, it's just going to be a ratio of sine of x to the power of 100 divided by cosine of x to the power of 100. Now, if you watched the previous video, we saw how we can actually integrate the tangent function by exploiting a very important type of integral, which is the integral of a rational function in which the numerator is the derivative of the denominator. And we have found before that the integral of this is just going to be a natural log of the denominator function plus some constant c. Now in this case we want to make sure that whatever appears in the numerator is going to be exactly the derivative of the denominator. So let's start off by differentiating that denominator. So we're going to start off with d over dx of cosine x to the power of 100. And that's basically going to give us the following. So we're going to apply the chain rule here. First, we're going to differentiate whatever is inside that function, which is going to be 100 x to the power of 99. And the next thing is we want to differentiate the outside function with respect to the argument. So that's just going to turn into a minus sign function. So we're going to place a minus here at the front, and that's going to become sine of x to the power of 100. Now, when you look at this function, this looks quite peculiar because we see that it is almost exactly the same thing we have in the numerator here. The only difference is this factor of minus 100. So what we're going to do is we're going to rewrite this integral in a more suitable form. So let's just make some room over here. So we already know what the answer should look like. We're going to place a minus 100 at the top, and then we have x to the 99 times sine of x to the power of 100, and then we're going to divide that by our cosine function, x to the power of 100 dx. And now, since we have included this extra factor of minus 100 in the numerator, just to make sure everything remains consistent, we're going to basically apply the inverse of that outside the integral. That's going to be minus 1 over 100. And the next thing is, well, this is already in the form numerator is the derivative of the denominator, so we can now apply that formula to find the answer. So we have the factor of minus 1 over 100, and then we're going to have the natural log of the function cosine of x to the power of 100 plus the constant c. And that's going to be our final answer. So it's quite interesting to see how we started out with a function that we had no clue about. We don't even know what that looks like. But we were able to find the integral simply by exploiting the property of the tangent function, which is the ratio of two trigonometric functions, sine and cosine. And then by noticing that the numerator was the derivative of the denominator, we were able to find an answer for this function that looks very challenging. So hopefully this has given you an idea of how you can actually apply this same technique to a whole range of integrals that look very tricky at first, but if you do the right manipulations, you can actually get to a very interesting answer. And in the next video, we're going to continue with more integration techniques. And as always, if you guys would like to see more content from LetThereBeMath, make sure you hit the subscribe button if you'd like to see more content, and I'll see you guys in the next video.